Hello, my name is Elliot Freiho. I'm an aerospace engineering student at the University of California, San Diego. Today, I will be talking about the autonomous powered paraglider. Recently, many kind of unmanned aerial vehicles have been researched and developed for various purposes such as land observation, surveillance, and reconnaissance of the ground circumstances. Most of them are fixed-wing aircraft, which are too heavy and large to carry equipment for observation and communications. Another type of UAV, an airship or an air balloon, also has a larger airframe in comparison with their payload. However, rotary wing aircraft and airships lack portability due to their weight and size. In contrast, a powered paraglider is excellent in portability since it's folded on the ground and enfolded when it flies. Although a paraglider is subjected to wind disturbances, the portability justifies the use of a paraglider as a UAV. The powered paraglider has an array of applications ranging from academia to defense. For example, with the increasing availability of consumer-level drones, academia is seeing an increase of the applications for aerial platforms. For example, the exploration of large geological areas that would otherwise be inaccessible by foot. The preservation of cultural heritage sites that are prone to disappear by natural disasters and wars waged by men. Another application is for the use of first response. In the case of an earthquake, an autonomous powered paraglider can be deployed to identify damages and look for survivors. It can also be used for communications, establishing mobile communication towers. Also, it can aid urban developers with rapid reconstruction plans. The powered paraglider is a platform that will be able to navigate aerial space, providing high stability and long endurance. The main purpose of the project is to provide researchers with a stable, modular aerial platform. It will enable scientists to accommodate visualization and communication payloads in order to generate panoramic pictures at high resolutions. One application of the project is to compile area images to generate 3D representations of the surrounding environment. Another application of the project will accommodate our communication payloads to determine the location of VHF radio collars. This year, we have studied three main platforms for the use of mapping and survey of the land: multicopters, fixed-wing aircraft, and foldable wing platforms. From the table, we can observe some of the characteristics of these platforms. If we look at the flight time of the paraglider versus the multicopter, we can see almost quadruple the time in the air. An autonomous paraglider allows us to maximize the flight time per payload ratio, making it one of the longest endurance survey platforms out there. The project is divided in three main sectors: software, hardware, and controls. For the embedded software, we have three main tasks. All these tasks will be fulfilled in the main loop seen here. The first will be collecting real-time data such as angles, speed, altitude, and location given by the external sensors. The second will be logging the data to the flash or the external drive for post-processing analysis. And the third and most important one is the RC controls to the platforms as a safety feature in the given case the control software does not work. The hardware used for the development of the software is the BeagleBone Black. It is a single-board Linux computer developed by Texas Instruments. It features an ARM processor that can be equipped with the robotic scape and external sensors. The robotic scape offers a comprehensive onboard hardware. It comes with a 9-axis IMU and a barometer, as well as a PRU accelerated ESC control, and many other features, compliments of James Strawson at the University of California, San Diego. The external sensors used in this project include a GPS from 3D Robotics, a speed sensor from 3D Robotics, and we hope to implement the use of an RFD900 to send telemetry to the ground. The mechanical design was broken down into three sections: design, assessment of design, and product development. As shown in this figure, a design is drafted and is passed along to product review, where the team makes a decision of what should be implemented and changed. Then, the design is manufactured. This includes 3D printing and product assembly. Once a completed prototype is inspected and passed along to testing, it is sent back to product review for completing one design iteration. After stability is achieved, we manufacture the last design and the product is finalized. During the last 10 weeks, we have gone through 3 design iterations, spanning from Paraglider 1.0 to Paraglider 2.0 to Paraglider 2.5. Some of the major design changes were the change of the thrust line on version 2.0 from version 2.1. The motor was placed above the center of mass, allowing for greater stability. We also increased the length between the tension lines to increase in-air stability. You can also see that we decided to go from a trike landing gear to a 4 contact point landing gear. The big changes from 2.0 to 2.5 was to improve portability. The nose cone proved hard to attach and remove, so we added a mini fixed lock and nut system to access the interior electronics with ease. The prop guard is now removable, and the carbon fiber tubes that attach to the tension lines on the canopy were repositioned to allow for an electronics bay to be easily placed. The back of the Paraglider has an opening for the speed controller wires to connect directly into the batteries, improving cable management. This concludes the third part of the project, the development of an autonomous control system for the powered Paraglider. Unfortunately, due to time constraint, we were not able to model the system dynamics of the powered Paraglider, but we will continue on with this project during the summer. I would now like to thank everyone who participated in the development of this project, as well as the people who have been funding the project. To the team members, thank you for all the support and great work, you guys. And thank you E4E and Season 3 for making this project a great development experience.